Hi, good day. Hope that you're doing well. So in this video, we're going to be looking into calculus. And to be specific, what we're going to be focusing into is finding the equation of your cubic function whenever you're given turning points. How do you find the equation of your cubic function if you're given your turning points? Now, these are the four steps that we're going to be looking into, right? And these steps, we're going to use them to find the equation of the cubic function, right? Now, starting off with the first step, it says that we need to first find the first derivative. Now, with regards to step two, it says now we need to substitute the x value of your turning point. So after you find the first derivative, you need to identify the turning point that you're going to use, right? So you substitute the x value of your turning point on your first derivative formula, then equate it to 0. From here, you're going to find equation 1. Now, step 3, we need to substitute the x value of the very same turning point we chose into the original equation. Now we're no longer substituting it into the derivative formula, right? We're no longer substituting it into the first derivative formula, but we're going to substitute it into the original equation. But now what's the difference afterwards? We need to equate this to the y value of the turning point. So step 2 and 3 are the most important steps. Now let me just repeat step 2 and summarize it. So you found your first derivative. Now what you need to do is that substitute the x value of your turning point in that first derivative formula, and after equate it to 0. Now, with regards to step 3, you need to substitute the x value of your turning point on your original equation, and after, equate that equation to the y value of your turning point. And lastly, you're going to solve simultaneously to find your variables. Now, let's see how would we apply that in a given question, right? Now, normally in your cubic function, you would have more than two variables that you need to solve for. In this instance, you have your a as well as your b, right? Hence, we're going to solve simultaneously because remember, you're only going to solve simultaneously whenever you're trying to solve for two variables at the same time, right? So let's apply these steps, right, which we have discussed above in this question. So this is the h of x graph that we are given, and we need to find the equation of this graph, all right? So let me just quickly do this. So let me just write it above there. So I have given my h of x graph, which is ax cubed plus bx squared. Let me see if I'm omitting something. So it's ax cubed plus bx squared only. All right. Now, let us follow these steps in order to answer this question, right? So I'm going to start off with the first step. We need to find the first derivative of this function here. So now I'm going to find my first derivative here. I'm going to multiply the whole term by my exponent. So this would be 3ax. And remember, use minus 1 from your exponent squared. And this is going to be plus 2bx. This is my first derivative formula. And I'm done with step 1. Now, step 2, let me write step 2 here. Step 2, we need to substitute the x value of your turning point on your first derivative formula. Now, let us go to the diagram that we are given below, right? So here we are given two turning points. So the first turning point is at point O, which is the point of origin, and the second turning point is at point B. Now, with regards to choosing the turning point that you're going to work on, as I've mentioned, you can choose any, but besides this turning point, which is at 0 and 0, right? Whenever you're choosing a turning point, try to choose the turning point that has actual values, right? Like, for example, let's say this graph had turning points at B, which is at, I'm just making an example, which is at 2 and 4, as well as at C, which is at 3 and minus 2. With regards to this one, you can either choose your C or your B, right? You can choose any because both of them, they have actual values. Now, with regards to the example that we're given here, I can't choose the point of origin. I'm going to choose this turning point at point B. This is what I'm going to use on my question above. So I'm going to choose point B, which is 4 and 32. All right. Now remember, I'm still on step 2. And remember, what is it that I need to do on step 2? I need to substitute the x value of my turning point in my first derivative formula. So doing so, it's going to be 3a multiplied by the x value of my turning point is 4 plus 2b multiplied to 4. And here, as mentioned, we need to equate this to 0. All right. Now, let me simplify. 4 squared, this is the same as 16, right? So this will be 3a multiplied by 16 plus here 4 multiplied by 2 to be 8, and simplifying further, 16 multiplied by 3, this would be 48. So this is 48a plus 8b is equals to 0. And as mentioned, this is going to be equation 1. I'm done with the second step. Now let me look at the third step. Now, step 3, I need to substitute the x value of my turning point in my original equation. All right. So now here is the original equation here. And I need to substitute my x value in this equation. So let me do so. I have a, and my x value of my turning point, as I've mentioned, it's 4. So it's a 4 cubed plus, here we have bx squared. So it's going to be b, my x, it's 4 squared. And in accordance to step 3, we need to equate this to the y value of our turning point, right? Now, what is the y value of my turning point? The y value of my turning point is 32, and I'm going to do so. So I'm going to equate this to 32. From here, I'm simplifying. So 4 to the power 3, this is the same as 64, so this would be 64a. And here 4 to the power 2, this is the same as 16 plus 16b. This is equals to 32. And now this is my equation 2. Now, the last step, which is step 4, we need to solve simultaneously in order to find our variables in this instance, to find a as well as b, right? We need to solve simultaneously. Now, with regards to simultaneously, there are many ways in which you could do that, right? But let me just show you how I do it. Now, I'm going to substitute equation 1 into equation 2. Remember, this is my equation 1. Let me go down. And this is my equation 2, right? So let me quickly change the color of my marker. So here, my first step with regards to equation 1, I can see that 8 is a common, or 8 is divisible on 48, right? So what I'm going to do here is that I'm going to try and make this equation to be in terms of, let me make it to be in terms of b, right? So I'm going to try and make this equation to be in terms of b by just simply saying, okay, 8b, it is equals to, I'm going to take the 48a to the other side, 48a, right? And this is going to be a negative, remember, when it goes to the other side. And dividing both sides by 8, my b value here, it will be equals to 6, right? So my b is equals to 6. Now, if my b value is equals to 6, can I find my a value? Yes, I can, right? So here, I'm going to substitute this 6 into this equation 2, right? So here is going to be 64a plus 16. And remember, I said my value of b is 6. This is equals to 32. And as a result, 6 multiplied by 16, this is the same as 96. Here it's 96. This is equals to 32. And here I still have 64a. Now, taking the 96 to the other side, it's going to become a negative. So 64a is going to be equals to 32 minus 96, right? So 32 minus 96, punching it into my calculator, I'm going to get negative 64. And here I have 64a. Remember, I'm solving for a, not 64a, dividing both sides by 64. My a is going to be equals to negative 1. So I found my a as well as my b, right? And remember, this was my h of x function. Let me just do this. This was my h of x function. Now let me substitute on it. My a, it's negative 1, so I can write negative x cubed. This is equals to my value of b, it's 6. And this would be the equation of my cubic function, right? Now, let's confirm. Remember here, they said we need to show that a is negative 1 and b is equals to 6, which is what we did here, all right? Now, with regards to finding the equation of your cubic function whenever you're given turning points, make sure that you follow these 4 steps. And the most important steps, as I've mentioned, is step 2 as well as step 3, right? Now, that'll be all for this video. Remember, if ever you have any questions, always feel free to reach out. Thanks.